Yes. So you can ask your doubt.
Sir, no, I understood, sir.
Okay. This is visible to you. The screen is
Yes, sir,
visible.
it is visible, sir.
Okay. 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 So this you have already done. Okay. You can try this.
Yes, sir. Let's have a control one.
So they are saying that x component of electric field at the point having coordinate 3, 1, 1 is 0. So calculate the value of q. So here you will have to write down the electric field in vector form. So electric field, because of the charge at the origin, it is a positive charge, so it will be in this direction.
Yes, sir.
Okay. And now they are asking you the value of, and if suppose because of the second charge it is in this direction, then will x component become 0? Adding these two vectors.
No,
Will
sir.
it will not become 0? Means what? Means the electric field due to second should be in this direction.
Yes, sir. In the direction only, sir.
Then only this is possible.
Yes, sir.
Okay, so simply write the vector equation, and then you automatically the E1 vector and E2 vector you will get in terms of I cap, J cap, K cap. Now you only have to add their I cap component and equate it to 0. You'll get the answer. Vector only. Concepts of vector only. Or you can also try by finding these distances and angle. You can try, but I think that may be lengthy.
Yes, sir. Better method will be the same.
Hmm. So you can use vector. See here they have also used vector form and calculated E1 vector, E2 vector, and then only they will add their x component and equate it to 0. So, or you can just add both and find the resultant vector, and in the resultant vector makes x component 0. Are you getting? So this is the resultant vector, the resultant electric field. And because the question is saying x component must be 0, so this term must be 0, right? Solving this, you will get this q, right? Understood?
Yeah, understood, sir.
Okay, so this was the concept here. These are simple questions, not any new type of concept. You can try this one. This one is still good. I think it involves some other concepts as well. You can try this. So if the disk is slightly displaced, then you will see that a component of force will come which will be in horizontal direction, right?
Yes.
Right now the force is vertical in this situation. So there will be no horizontal motion. Net force in horizontal direction right now is zero. But if you displace the disk little bit by a small displacement x, but then here you have to understand that it is the disk will not slide, it will do pure rolling. Now you have to find the period of oscillation of the disk. You know there are different ways to do it. One is by energy method you can do it, because you know that in SHM, first of all you have to prove that this is a SHM or not. And if it is SHM, you know that in SHM the total mechanical energy of the system will remain conserved. One way is to write down the force, a torque equation or force equation, and find omega. So if the disk will is displaced slightly, now will this force produce a torque about the point of contact? Right now the line of action of force will pass through the point of contact, right? Right now line of action of force will pass through the point of contact, so it cannot produce any torque about the point of contact, right? But if you displace the disk slightly, and now this becomes the new position of the disk, now the line of action of force will become this, right? And now it is not passing through the bottom point of contact. Can you see? Now this force can produce a torque about the point of contact, which will rotate this disk. Are you getting? When you will release, friction is sufficient to prevent the slipping. Here you have to understand that slipping is not there, so friction will be there, but friction will not do any work because point of contact will be at rest. So non-conservative force is not doing any work, so mechanical energy of system will also be conserved. So you can write the equation of mechanical energy after displacing it, after giving it a slight displacement x, you released it. Suppose it started moving with velocity v, center of mass is moving with velocity v, and the disk is rolling about the center of mass with an angular velocity omega. And because it is pure rolling, so v is equal to r omega. Now you write the total mechanical energy of the system. In the total mechanical energy of the system, three terms will come. Electrostatic potential energy will come, translational kinetic energy and rotational kinetic energy will come, and then that mechanical energy is equal to constant, and then you can differentiate this equation. After differentiating, you'll get something. Ultimately, you have to find omega, because to find time period is 2 pi by omega. But now how omega will come? Omega can come from equation of alpha also, right? Omega square theta. If you want to express it in terms of theta, think about this question, try this question, apply all the concepts of
Yes, sir, I'm coming,
electrostatics
sir.
and the SHM. Yeah. So I have another class from 7:30. It's already 7:25.
Yes, sir, okay.
So you can try this question, and then you have doubts, you can ask. Next class we will discuss this.
Yes, sir, okay, sir. Yes.
Or on WhatsApp, if you want, you can send your doubt, your solution. You can discuss it. Also, you know that in case of accelerated pure rolling, there is one more relationship between A and alpha, right? A is also equal to R alpha, right? So do it, take your time, and once you get the solution, you can also send me the solution on WhatsApp. Okay.
Yes, sir, I'll send.
Okay, then we'll continue in next class. So you will continue tomorrow.
Yes, sir, I will continue.
Okay. Okay, then.
Thank you. Yes, sir.
Okay, bye. Okay.